Question number 9, part B. If x is a number chosen at random from set A and y is a number chosen at random from set B above, calculate the probability that the numbers chosen satisfy the condition that x into y is odd. Now, there are two ways of doing this question. The first method is to create a sample space similar to the one that we created for part A. So we write down the possible values of x in the first row as 1, 2, and 3, 4, and the values of y in the first column as 3, 5, 7, 8, and 10. Now, inside the remaining columns, we can write down the possible values of x into y. Question wants us to figure out the probability that x times y is odd, so our first task would be to write down all the possible values of x into y. If x is 1 and y is 3, then 1 times 3 would give you 3. If x was 2 and y was 3, you'd get 2 times 3, which is 6. If x is 3 and y is again 3, you get 3 times 3, which is 9. And if x is 4 and y is 3, we get 12. So in the output row, the first output row, we have 3, 6, 9, and 12. Now let's fit the remaining output rows as well. So we get 5 and 10 and 15 and 20 in the second output row. In the third row, we get 7, 14, 21, and 28. In the fourth, we get 8, 16, 24, and 32. And the last one, we get 10, 20, 30, and 40. As you can see, the total number of possible outcomes in this case is going to be 4 times 5, which is 20. The question says, what is the probability that x times y is odd? Remember, the formula for probability is equal to the number of favorable outcomes divided by the total possible outcomes. The total possible outcomes in this case were 20, so that is your denominator. In the numerator, you just need to simply count from the output sample space how many odd outcomes we have. So we have 3 and 9 from the first row, 5 and 15 from the second, 7 and 21 from the third, and that's it. We do not have any further odd values for x times y. So there are 6 favorable outcomes. That is your numerator. So the probability that x times y is odd is going to be 6 upon 20, which is equal to 3 upon 10. This was the first way of solving this question. Now let's talk about the second way of solving this question. The second way of solving question number 9 part B is that you need to remember that if you want to multiply x into y and get an odd answer, there's only one way to do that. For x times y to be equal to odd, both x and y need to be odd. X must be odd and y must be odd, because the only way that you can get an odd answer by multiplying two numbers is if both those numbers are odd. Now, the possible values of x are 1, 2, 3, and 4. Out of those 4 values, 2 are odd. So the probability that x is odd is equal to 2 upon 4. For y, there are 5 possible values, 3, 5, 7, 8, and 10. Out of those 5 values, 3 are odd, 3, 5, and 7. So the probability that y is odd is going to be 3 upon 5. Now, if you want both x and y to be odd, the probability of both x and y to be odd should be equal to the probability that x is odd multiplied by the probability that y is odd. Because there's an AND condition here, we will be multiplying the probability that x is odd with the probability that y is odd. Now, the probability that x is odd, as we saw, was 2 upon 4. And the probability that y is odd is 3 upon 5. So multiplying 2 upon 4 with 3 upon 5 will give us 6 upon 20, which again simplifies to 3 upon 10. I hope the second method was also clear to all of you.